Hello explorers, it's that time again. It's Advent of Code, finally! And as normal, you can join the channel as a Christmas explorer and see all the uncut content before. Day 17, Clumsy Crucible. The lava starts flowing rapidly once the lava production facility is operational. As you leave, the reindeer offers you a parachute, allowing you to quickly reach Gear Island. As you descend, your bird's eye view of the Gear Island reveals why you had trouble finding anyone on your way up. Half of the Gear Island is empty, but the half below is a giant factory city. You land near the gradually filling pool of lava and at the base of your new lava fall. Lava ducts will eventually carry the lava through the city, but you make use of it immediately. Elves are loading it into large crucibles on wheels. The crucibles are top heavy and pushed by hand. Unfortunately, the crucibles become very difficult to steer at high speeds, so it can be hard to go in a straight line for very long. Go to Desert Island. The machine parts will needs as soon as possible. You need to find the best way to get the crucible from the lava pool to the machine parts factory. To do this, you need to minimize the heat loss while choosing a route that doesn't require crucibles to go in a straight line for too long. Unfortunately, the elves have a map, your puzzle input, that uses traffic patterns, ambient temperatures, and hundreds of other parameters to calculate exactly how much heat loss can be expected for a crucible entering any part of the city block. For example, each city block is marked with a single digit, representing an amount of heat loss if the crucible enters that block. The starting point, the lava pool, is top left city block, and the destination, the machine part factory, is the bottom right city block. Because you are already starting in the top left block, you don't incur that block's heat loss unless you leave that block and then return to it. Okay? Because it's difficult to keep the top heavy crucibles going in a straight line for very long, it can move at most 3 blocks in a straight direction before it must turn 90 degrees left or right. The crucible also can't reverse direction after entering each city block. It may only turn left, continue straight, or turn right. One way to minimize heat loss in this path never moves more than 3 consecutive blocks in the same direction and incurs a heat loss of only 102. And directing the crucibles from the lava pool to the machine part factory, but not moving more than 3 consecutive blocks in the same direction, what is the least heat loss that it can occur? Okay. So we need to figure out a path that is the best for this. I think I solved this once by just traversing and trying to find the smallest number that I could hit for each spot. First off, we need this map. I think we can continue to use lines, add a line here. When we have done that, we need to create another one. And here I think I will use integers. Map. New integer. Lines. Size times. I think it's square. Now we need to figure out how to get to a particular point. from all directions. And if we have visited that point already, because we can't go back, is it better to have a class figuring out? Let's do that. Crucible. Let's create a Crucible class in the Java source directory here. So we have a package, day 17, new Java class, Crucible, processed class. So this needs to have a processed. It needs to have an int x. An x and a y. Then we need to have a private int direction. And this is the direction we are moving in. So public final public static final int north south west east. And we also have to have a private int moves. That is how many moves we have gone so far. And create a public Crucible. X, Y, direction. Public void calculate neighbors. I don't know how that spells, but we have here a Crucible map. We also need to have so this can be a long moves, and we also need to have consecutive moves. Or something like that. No, I don't know how that spells either, but these are how many moves we have gone so far. So map x or y times map or width plus x. So there we go. So now we have a Crucible. list of string heat map. We can close that so we have more space. Get heat for these two x, y, x plus 1 I, get moves, create method get moves, return moves. If that is true, then this position we get the new crucible y, and these moves yeah, whatever that is. Yeah, something like that. I don't think I need this either. Y substring x plus 1 x plus 2 integer parse int. So this is something like what I want to do. Extract method. And let's call that do move, something like that. New x, int, new y. So so now we need to figure out if direction is equal to north. We need to do 3 of these. There we go. So if we're going north, then we can either go to the left, to the right, or continue north. Like that. And here we could say north. Nope. This should be east, north, west. And these are the consecutive moves. Plus 1. And if consecutive moves is larger or equal to 3, so both of these are 0. And this, we just need to check that it's less than 4. Because we can take up to 3 moves. And we also need to handle the case where these new positions are outside of the board. If mu x is less than 0, or mu y is less than 0, or new x, it is returned there. So we don't do anything there. We don't add anything to that position. Now I think we have a class. And then we can take map 0 new crucible. And this should have 0, 0. I guess it has north. No, south. And what did I say more? Moves 0 consecutive 0. And I think we will do 1 move in that direction when we do our first, so not 0. For crucible in map, if C is not null and C is not processed, while Boolean all processed false, while not all processed true, and here, if not all processed false here. See, what do we have? Calculate neighbors, list, map, and then list size. I just realized that we can't really look for the shortest path to every place, because in this specific case, one of the places where it was longer to get to a particular place, but with shorter consecutive spacing, that was a better choice for this one. So I need to weight those in some way. And what I think is that if the move set, I wonder how I weight that. I need to change this up a bit. So a list of crucible. Plus 10. So we have a little bit of a restriction. We can't do a lot more moves than the current one. That would be unreasonable. Found equal. False. So if we go in here, crucible, it moves equal to that. If those two are true, then we found an equal. And then we just return. Because don't want to add something that is the same. Map. Long small list. Long max value. Less than smallest. Then smallest equal to C get moves. I just turned off the camera and realized that I need to check the direction as well. So now we have 102. If we change this to 3, so we don't get that many, I think we still will get 102. Let's hope. Yes. So now we have the right value there. Let's see if we can run it with the full example without it crashing or overheating or anything like that. And I got a value. Not sure if it is the correct value, but it is a value. So let's put that in. See what we get. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So a lot of things have happened to this code here. A lot of debugging, but it's pretty similar to before. One of the things I had to do was creating lists of crucibles. So we have a list here, and I also created a boolean of done maps. We actually know which of all these lists are done, or else it would take forever to run through. So what I do is create a bunch of array lists here into the map. So the full map is filled of array lists. We add a first to the first point here. And when all is processed, we will end. And the processing is with an outer loop running through the whole map. And if this particular position is done, then we just continue, don't do that. And if we have gone through the full list here without finding anything that it needs to be processed more, then we will set that this particular point is done. And the list is not empty, of course. Here we will break out of the loop and continue at the top. And all process is set to false, so we will do another loop. And when we calculate neighbors, what do we do then? Well, we had this as before. We go through, if it's the north, we will try to move east and west, and then also north, if we can do that, if we haven't done more consecutive moves than possible. And the move function, we will check that we aren't outside of the map first. Then we will get the next heat value that we want to move to. And we will also go through the whole list of the new position and see that the consecutive moves, the current moves that we want to set, and the direction isn't the same one, because then we don't want to create another crucible in the same position in the same list. That would be bad. could probably do this into some kind of a check against contains or something like that, but I didn't add a hash function or anything like that. And then here we have this, if it's not, this particular map is empty, or if the map is containing a move that is less than 3 extra. So I would say that, okay, this can be a little bit longer, but not super long. So 3 extra moves, that's fine. And then we will add a new heat to that, and we will add a new crucible, and we also will check this done map here and set the false in this position, so we actually go through this and process it again. So this was a huge time saver. I ran this for like 2 hours, and then I realized, okay, I need to have a done map in order to get it. So now it only took half an hour or something like that. So we have the first one. I wonder how they will make this so much more complicated that we can't do it. So that's probably part 2. This video series is sponsored, so for all your hosting needs, go to DigitalOcean. If you want to learn something new this Christmas, then you can go to Coursera, take any of those 7,000 courses over there, or follow along with the simple Java course that I provided as well. And if you want to give your kids something really great for Christmas this year, you can give them a one-on-one course with a Code Combat trainer in order to learn coding. All the links can be found in the video description. The crucibles of lava simply aren't large enough to provide an adequate supply of lava to the machine parts factory. Instead, the elves are going to upgrade that to ultra crucibles. The ultra crucibles are even more difficult to steer than normal crucibles. Not only do they have trouble going straight line, but they also have trouble turning. Once the ultra crucible starts moving in a direction, it needs to move a minimum of 4 blocks in that direction before it can turn, or even before it can stop at the end. However, it will eventually start to get wobbly, and ultra crucible can move a maximum of 10 consecutive blocks without turning. Okay. In the above example, an ultra crucible would minimize, and then we get 94. Okay, 71. So we have another extra example here. It needs to move a minimum of 4 blocks in that direction before it can turn. So we need to move 4 blocks before we can turn. That means that we need to change our move function a bit. That first example, because we will do that as well. Can go 10, needs to go 4. So it's only changing the move function actually. I got 94 moves after a little bit of looking, and I think the reason is that we needed to change this up, number of moves here, to max. So I have the max number of allowed extra moves there, because I realized that when we came to one position, the value we wanted to go from was 43, and the new value that was in that position was 42, which meant that we couldn't really end up there. So we got 94 here. They had another example with 99999. So I will try that example as well and see if I get the right answer for that one as well. Put it in here. Run that through. And we are back. And I pretty much just changed this up so we have max moves here. And we got a value. So let's see if that's correct. Otherwise, I need to run a bunch more. Let's see here. Yes! You get a gold star! I get a gold star! Everybody gets a gold star! So, let's see here. What did we do? First off, we had this day 17 here. We went through the full list of this here. And I tried it with a smaller example, but it wasn't square. That was the problem. But what we do is pretty much we have this map with a bunch of lists. We add to the lists, we add the east and south direction, which is the two first directions that we can go into. Then we have this list here where we go through all of them. We have an outer loop that we loop through. And this loops through all the full map, and then we also loop through all of the lists. And we get one list, and if that list doesn't find anything inside here, we will set that is done. We have gone through all of them and they are processed. If one of them is not processed, we will calculate the neighbors and we'll set all process to false. So somewhere here we'll set this to false and then start another while loop. If everything is done, we will set smallest to the max long value, go through the full loop here and find how many moves all the map crucibles has, and of the last one, so just the last point, we will find all the crucibles, go through and find the smallest one of those and print the smallest. Calculate neighbors. We have seen this before. The only difference is that if we want to turn, we have a minimum value of 3, so it must be larger than 3 if we want to turn, and we have a max value of consecutive moves of 10. So that is the requirements we have in order to turn or to go forward. And in this function here, the thing we had to change here was the max amount of moves that we could take. So here we had 3 before, now we go all the way up to 10 moves. That is the max. But other than that, the code is the same. So this was today, day 17 of Advent of Code. I hope that you found this interesting. If you solved it in a different way, and I really hope you did, leave a comment down below and explain how you did it. If you liked this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.